another type of equation that we're interested are radical equations. And like the name suggests, what are these? These are equations that contain radicals in them, right? So, number one is super silly, but it's a radical equation. Right? It's a radical equation. Now, number two is slightly more interesting. It's an equation that has a radical in it. Okay? So this is the kind of equation, and you don't have to have one radical. You may have two, three, as many radicals as there may be. Now, if there are two radicals, we will learn how to deal with them. If there are more than two radicals, it's more complicated. Okay? It just becomes a mess. But it's what it is. It could happen. Anyways, we're interested in being able to solve in a reasonable way this type of equations. And as we discussed earlier, for example, number one, what do you do to solve for x? Just square both sides, right? So the whole point is, okay, we have radicals. Well, let's try to get rid of the radical. How can we get rid of the radical? By leaving it alone on one side, and then we square both sides. We raise both sides of the equation to a power matching whatever the index is. If it's square root, you square. If it's a cube root, you cube, and so on, right? So in this case, the reasonable thing to do is square both sides, and then we immediately get x equal 4. Now, you're gonna see pretty soon that this is a dangerous thing to do. Okay? Squaring stuff, as I mentioned last time, may introduce solutions that are not there. So you may obtain strange solutions because when you square things, weird stuff happens. In the sense that things that were different could become the same. For example, 1 is certainly not the same as -1, right? But what happens if I square both sides? They become the same. So you have to be careful. When you square things, when you're solving an equation and you're relying on squaring both sides, you have to be careful because things that were not solutions before could all of a sudden become solutions. So what that means is that when you solve radical equations, don't trust what you obtain 100%. You have to go back always and plug in and check and make sure that you actually have a solution in your hands. Because it could be that one of the solutions is not good. Okay? So here checking is important. So far we have not been checking. Right now it's important. Yes?
So for one, there could also be a convex solution?
No, for one, that's the solution. 4 works. It's just that, for example, in 2 we're going to see that there will be 2 solutions popping up. One of those is not good. And the only way to spot that is you have to plug it. Okay? Yeah, no, again, we don't know how to take square root of complex numbers. In fact, you need to know trigonometry for that. Okay? Because if I ask you what's the square root of I, because for complex numbers, like for real numbers, the square root always give you one number, right? Like square root of 16 is just 4. Now for complex numbers, square root is no longer a function. It's what we call a multi-value function. So you actually are going to have as many roots as the index. If it's square root, you're going to have 2 roots in here. In fact, you have infinitely many, but the ones that we call the primitive roots, there are only 2. Okay? But if I do cube root, then there will be 3 primitive roots, and so on. So it's more complicated when you have complex numbers. Anyways, the point here is be careful when you are raising both sides to a square. Okay, so you need to keep that in mind. Okay, but here x equals 4 works, and then of course if we check, typically we just visually check. Right? You just write it down, put the 4 here, and then the question is this equal to 2? And yes, it is, so we're good. Now, this super simple example generalizes to any other radical equation that you may encounter. So what's the idea? When you have an equation, isolate the radical. The first thing is leave the radical along one side, and then you raise both sides to a power matching the index. The radical will be gone, and then you solve the remaining expression that you obtain. Whatever equation you have left, you solve it. For example, for number 2, what do? What's the first thing to do? If you square both sides here, the left-hand side is going to be a mess because it's a binomial. The radical is not going to disappear. Do you understand this? You have to distribute this first square plus the last one square, but then there's another term. What is it? The product of these 2 times 2, right? So remember, a plus b squared. How do you do this? This is a squared plus 2ab plus b squared. So when you square a sum, it's not just b squared plus b squared. It would be nice if that was the case, but it's not. There is this middle term that pops up when you do the distribution. Okay? So the radical is not going to be gone. So the first thing is isolate the radical. So you have to move the 3 over. Yes? Subtract 3. Now the radical is by itself. Now we can square both sides. So now square both sides. The left hand side, the radical is gone. So we have 2x plus 3. And now the right hand side, we have x minus 3 squared. What is x minus 3 squared? Yes?
Why do you change that instead of the radical from 2 to 3?
Oh, I don't know. That was to see if you were paying attention. Yeah, I don't know. Thank you. Okay, so what's x minus 3 squared? So, you know, you either...
X squared minus 6x plus 9.
Exactly. So you either write x minus 3 times x minus 3 and, you know, distribute, or it's very helpful to remember this little formula. Okay? So it's the first guy squared minus the product of the 2 times 2. So that would be 6x. So minus 6x plus the last guy squared. If it is a minus here, then you have a minus. Okay? And now what do we have? A quadratic equation, right? So we solve this. So how do we solve quadratic equations? Move everything to one side. So let's see, subtract 2x, so we get negative ax. Subtract 2, what do we get? 7. So here we can factor this as x minus 7, x minus 1. So we get x equals 7 or x equals 1. So two solutions pop up from here, right? Now the question is, are these the solutions to the original equation? You don't know, you have to be very careful here. Okay? You have to be very careful. So you need to check, you either plug in manually or you visually inspect it. For example, you already should realize that 1 is superficial. Why? If I put a 1 here, on the right, on the left, I have 3 plus something that's positive, because square root of whatever is always positive, right? There is no way that 3 plus something positive will give you 1. Understand it? So 1 out of the equation. Anyway, you put it, what do you get? 4 inside the square root, so that's 2 plus 3, that's 5. 5 is not equal to 1. So we immediately see that this is not good. We call this an extraneous solution. Okay? And then 7, let's see, let's visually inspect. So if you plug in 7 here, what do we get? That's 14. 14 plus 2 is 16. Square root is 4. And 4 plus 3 is 7. So we're good. So you either visually inspect it or you write down the check, plug it in and see. Okay? Because this kind of stuff is very common when you're solving. Or it could be that both of them work. Okay? All right. Questions? Okay, good. Then let me just do one more, a little bit more complicated, and then call it a day. So let's do square root of x plus 1 plus 3 equals square root of x plus 5 plus 2. So what do you do when you have 2 square roots? Notice that I could have also written this minus this square root and then equal to negative 1 or something like that. Okay, the point is when you have 2 square roots, the idea is that you may need to do this process twice. Okay? So do not put the 2 square roots on one side and then square, because they're not going to cancel and you're going to create a mess. Okay? So what you should do is isolate, pick 1 or 2, whichever you want, leave it alone on one side and move everything else to the other side. Okay? Like in this case, I'm going to move the 3 to the other side. So I'm going to have this. Okay? So subtracting 3. And then at this point, what I'm going to do is I'm going to square both sides. Now, by doing so, I'm going to get rid of the square root on the left, but understand that the one on the right will remain. So what do you do? After you simplify, isolate that square root that remains, and then square again. So we need to do the squaring process twice. Okay? So squaring both sides, you're going to have x plus 1 here. And now on the right, it's very useful to use the formula. It's the first guy squared, which is just x plus 5, right? Minus 2 times the product of these two. So it will be 2 times this, which is just this, and plus the last guy squared, which is just 1. I'm using this formula, okay? The one that I put up here. If you don't want to remember the formula, you should, because it's helpful. Just multiply this by itself and this 3, okay? After you do that and simplify, you're going to obtain this. And now, notice that we have an equation that only has square roots in it, so let's isolate it and repeat the process. Now here, nice stuff happens. Like the x's cancel out because they are on the same side, on different sides of the same symbol. The 1's cancel out, so we end up with, let's see, I'm going to bring the square root over here. Equals to 5. Now here it's okay, I could divide by 2, but if you divide by 2, then you're going to have 5/2, then fractions will pop up. It pops up, and then when we square, you have to deal with the fractions. It's more comfortable if we just leave it like this and we square at this point, okay? So, if you have a coefficient, it's fine. I would just get rid of the coefficient if I know it's going to cancel nicely on the other side. If it doesn't cancel, I just leave it there. Now I square both sides. So we get, remember when you square the product, you need to square both guys, okay? So that's 4 times x plus 5 equals 25. So that's 4x plus 20 equals 25. So 4x equals 5, and x is 5/4. Now, what do we need to do? We need to check, okay? So let's see, let's check. And here, I guess, should plug in. So let's check. So the left-hand side, it will be square root of 5/4 plus 1, and then plus 3. So what is this equal to? So this is 4/4. When you add, you get 9/4. So that's square root of 9/4. Plus 3, square root of 9/4, that's 3/2. And what's 3/2 plus 3? That will be 6/2, so that's 9/2, right? So that's what we get in the left-hand side. What's the right-hand side? Square root of 5/4 plus 5, and then plus 2. So it will be 20, so 25/4. So that's 5/2 plus 2. Multiplied to one more by 2, so that's 4/2, so we get 9/2. So now we can claim this as a solution.